In early 2025, California experienced a strange swarm of earthquakes, not strong enough to devastate cities, but frequent enough to unsettle scientists. Months later, over Europe, meteorologists recorded atmospheric patterns that didn't quite make sense, pressure systems behaving oddly, electrical disturbances lingering longer than expected. Nothing catastrophic happened, but the question lingered: what if these weren't random events at all? What if the Earth was trying to tell us something quietly? Because long before disaster strikes, our planet doesn't scream, it whispers. Subtle signals, faint anomalies, warnings hidden in plain sight. And that brings us to a critical question. In an age of satellites, supercomputers, and artificial intelligence, are we truly listening? Or are we still missing the signs that matter most? When we think of earthquakes, we imagine violent shaking, buildings swaying, roads cracking apart. But major quakes rarely arrive unannounced. Deep beneath our feet, the Earth is constantly moving. Scientists have observed microseisms, tiny, almost imperceptible vibrations occurring days or even weeks before large earthquakes. Groundwater levels can shift mysteriously, and in some regions, spikes in radon gas, a radioactive element released from stressed rock, have appeared shortly before major seismic events. The challenge: these signals are subtle, and they're everywhere. To help decode them, researchers now rely on satellite-based deformation monitoring, known as INSAR. From hundreds of kilometers above Earth, satellites can detect ground movements smaller than a few millimeters. Combined with dense GPS arrays, we can now watch tectonic plates slowly strain in near real time. But here's the problem: the Earth is always active. Separating a genuine warning from everyday geological noise is like trying to hear a single whispered word in a crowded stadium. The ground isn't the only messenger. Sometimes the sky reacts too. For centuries, witnesses have reported strange atmospheric phenomena before earthquakes and volcanic eruptions: glowing lights near fault lines, oddly shaped clouds, sudden electrical disturbances. These so-called earthquake lights were once dismissed as folklore. Today, laboratory experiments and field observations suggest they may be linked to electrical charges released as rocks fracture under extreme stress. Even higher above us, the ionosphere, a charged layer of Earth's atmosphere, has shown measurable disturbances before some major earthquakes. Satellites have detected shifts in electromagnetic fields and electron density hours, sometimes days, before the ground moved. It's an exciting frontier, but a complicated one. Atmospheric systems are chaotic by nature. Solar activity, weather patterns, and human technology all interfere. So while the signals are real, their reliability remains uncertain. The sky may be speaking, but its language is frustratingly difficult to translate. Long before satellites and sensors, humans looked to animals: dogs refusing to settle, birds abandoning nesting grounds, fish beaching themselves without explanation. Stories like these appear throughout history, from ancient Greece to modern Japan. Today, science is cautiously revisiting these accounts. Researchers are using biologging devices, GPS trackers, and automated behavior monitoring to study how animals react to subtle environmental changes, vibrations, electromagnetic shifts, even chemical changes in water or air. Some studies suggest animals may sense danger hours before humans can measure it. But relying on animals raises difficult questions. Behavior varies. False alarms are common, and there are ethical concerns about turning living creatures into biological sensors. Animals may feel the whispers, but interpreting their reactions remains deeply complex. This is where the future begins to change. Artificial intelligence doesn't get tired. It doesn't overlook patterns, and it thrives on complexity. Machine learning systems are now being trained to analyze vast streams of data simultaneously: seismic readings, satellite imagery, atmospheric measurements, animal movement, and even reports from citizen scientists around the world. Individually, these signals may mean nothing. Together, they might form a sentence. The vision is bold: a globally interconnected network where sensors, satellites, AI models, and human observers work as one, continuously listening to the Earth in real time, not to predict the future with certainty, but to gain precious minutes, hours, or even days of warning. Because resilience isn't about controlling nature, it's about understanding it. The Earth has always spoken. The question now is whether we're finally learning how to listen. And if we do, the future may be safer because of it.